In today's video, we are going to see about the soil-water-plant relationship. As we all know, for a successful farming or agriculture, the soil and water are the two essential components. The soil and water forms a relationship with plant. We can call it as a triangular relationship in which none of the components are separated. So they are interdependent among each other. And this interaction between these three components are very critical for maintaining the ecosystem processes. And the balance between these components supports global farming or global agriculture, and it can boost the agricultural productivity. If the balance is optimal and the balance is on a positive side, one can expect increased productivity in agricultural crop. So as agriculture graduate, we have to understand the balance between these three components, which is the need of the hour to boost the plant growth and for sustainable agriculture. If you take the plant has the ability to respond to the water deficit or water stress that happens in the soil. So as we all know, the soil water can be categorized into hygroscopic water, capillary water, and gravitational water. Among these three categories, capillary water, which is against gravity, is available to the plant system. When the capillary water is not available in the soil, the plant undergoes a stress. So this stress in plant is responded or is managed by several inherent mechanisms of the plant. One is the stomatal regulation. So stomata are minute pores which are present on the leaf surface, which we have studied in our lower classes. Stomata is responsible for the opening, which can control the transpiration process that is happening in the plant system. So by regulating the stomatal opening, the plant could be able to conserve water during stress, that is by slowing down the transpiration process. The second feature or the mechanism is adaptation. So if we take the plant system, they have the inherent ability to adapt if the water deficit prevails in the soil. So it can modify the root system architecture by increasing more number of root hairs, root volume, or the root can elongate much deeper to take up the water, to enhance the water uptake. So the adaptation plays a major role. And the hormonal signaling is yet another physiological phenomenon which happens by this abscisic acid and ethylene. So these hormones act as a signaling molecules, and it can modulate and it can activate certain gene cascades so that the plant could be able to respond to the water stress so that it can able to survive. We have to understand that the drought tolerance or the resilience ability of the crop plants varies by species. Certain plant species, they can tolerate moisture stress, while some other crop varieties are much vulnerable to the stress, so they cannot able to withstand the drought or the lack of soil moisture. So another important characteristics is the soil characteristics, which plays a crucial role in the soil-water plant relationship. So in previous units, we studied about how irrigation scheduling can be done based on the evapotranspiration patterns. So in this lecture, we will dive more into how the soil available moisture all plays a crucial role or a vital role in scheduling irrigation. So as we take the soil, it is made up of different components or composition, of which mineral occupies the major component, that is 47%, and air and water is shared by 25% each, and a small fraction of organic component which comes from the root of the plant system. So the basic soil water plant relationship, as I discussed earlier, are very, very important for optimizing the good management practices for your soil and also for scheduling the irrigation based on the soil moisture content. So nowadays, many sensors are coming up to automate to irrigate the soil automatically based on real-time monitoring using this sensor. Available soil water as well as the texture, they go hand by hand, and the water content in the soil is decided by the soil properties, and no doubt in that. So if you know the soil property, you can have your own decision, or you can have your own choice of crop, and also you can schedule when to irrigate and when not to irrigate. So five physical characteristics of soil are very important, of which soil depth, texture, structure, bulk density, and soil porosity. So we will be exploring one by one in the next videos. So if you see this picture, you can see the soil particles are arranged in a very systematic manner, and there exists some intermolecular spaces or the void spaces which are occupied by the air and water. And you can see the root component which contribute to the organic fraction of the soil. And what do you mean by the pore spaces? So the intermolecular spaces between the soil particles, we call them as soil pores, which can able to store air as well as the water. So the amount of air and water present in the soil pore varies over time, and they have inverse relationship. Suppose if you irrigate your soil today, the pore space will be occupied with water, and if it is raining or the soil received considerable amount of rainfall, the soil pores get saturated. And we have already studied about the field capacity and permanent wilting point. You can recall that. So field capacity is a condition when all the soil pores are filled. In other words, when they are in a saturated condition. So permanent wilting point is that is the minimal amount of water, and beyond that the plant cannot able to extract even a single drop of water from the soil. So the first physical property is soil depth. So what is soil depth? So if you take any soil, so the root can able to penetrate up to certain level. Beyond that, you can find some hard substratum which will prevent the penetration of the root. So the thickness of soil cover over a hard rock or any hard substratum below which or beyond which the root cannot able to penetrate, we call that as a soil depth. So how does the soil depth influences the soil water availability? The soil depth influences the root system development. Only up to that hard substratum level, the root can able to grow and it can able to penetrate. And moreover, the soil depth influences the water storage capacity of the soil. More the depth, more water storage ability, as well as it also influences the nutrient supply. Based on the soil depth, one can decide what uh, field preparation operation can be carried out, which type of leveling, which type of shaping, whether we have to plow deep or we have to pulverize, or what are the special operation we have to carry out, it can be decided based on the soil depth. According to Soil Conservation Division, Ministry of Agriculture, New Delhi, they have given a soil depth classification. There are 5 different classes of soil based on the soil depth, starting from say less than 7.5 centimeter to more than 90 centimeter. So if we take the soil depth, if it is less than 7.5 centimeter, you can categorize them under very shallow class. So you can grow very tiny plants like your grasses or some very annual crops in under this condition, and 7.5 to 22.5 is categorized as shallow, and 22.5 to 45 centimeter are categorized as moderately deep, which is favorable for most of our crops, most of our annual crops, field crops like your rice, your maize, etc., and your vegetables. And 45 to 90 centimeter is considered as deep, which is required for your crops like red gram and other crops. And more than 90 is ideal. It is considered as very deep class, and it is ideal for growing your perennial crops like your tree crops. So in this video, we explored about soil-water plant relationship, and we saw the relationship is very crucial for maintaining the ecosystem. And we studied about the inherent ability of the plant to manage the water stress by three mechanisms such as stomatal regulation, hormonal signaling, as well as the adaptation, especially the root system architecture modification. Then we studied how the soil characteristics, physical characteristic influence the soil moisture, especially the depth as well as the texture. More the depth, the soil water storage ability will be more. And we will explore the depth, the texture as well as the structure in the next videos. Thank you.